Hello, I'm Keith Kreischer, Executive Director of the IoT End-to-End Council, coming to you from Embedded World North America in Anaheim, California. And I'm here with my good friend Roland Lindsey of Finite State. Roland, good to see you.
Good to see you.
How's the show going? It's a new venue, new show?
It's great. Yeah, it's our first time here, and we've had great interactions with customers. One of the great things about this show, the folks are really well qualified. They care about embedded systems. They care about developing, and it's fun. They're just walking around with their engineering samples saying, look at this thing I work on. Can you help me? It's good stuff.
Right. Talk to us. I mean, Finite State, obviously, well known in security circles for IoT and embedded. You guys are doing audits. You're doing, real-time monitoring, testing, all sorts of things. Talk to us about the concept of meeting compliance. How does Finite State facilitate that for its customers?
Yeah, so compliance is an area where a lot of our, it brings a lot of our customers to us. They need to meet NIST, they need to meet CRA, they have a number of different governmental requirements that they need to meet. So they come to us and they say, hey, look, we've been doing this manually. Is there a better way to meet these requirements? So what we do is, number one, all of our work is around filling up an SBOM with what's inside that firmware, along with its related security information. That then gives the various regulatory bodies what they need to meet their needs. In addition, we also, in our product, will say, hey, this is outside of the, this particular regulation, and so you can get a report and fix those missing gaps. Ultimately, our product is built primarily to solve those compliance problems and give people what they need to get through those processes quickly.
And talk to us about the progression from compliance to security,
Oh, yeah.
or the other way around.
No, absolutely right. So a number of clients, I would say most clients, start off with compliance. That's what they need to get done. And then they find out, hey, the security information, and that security information becomes very relevant, very valid, and so they move deeper and deeper into that. And then we have other customers who they come in and they say, we want security. We heard that we can get a lower risk, a higher security profile if we use your product, and that's generally what they find.
Terrific. I'm curious about the concept of reachability in a security platform. So, what is it, how does it work, and why is it important?
We're really excited about this. I've been working in this field for a long time, and this is one of the most exciting advancements I've seen. And the reason why is because, when you've been working in security for a while, all these tools provide, here, we scan this thing, and there's 1,000 findings or 10,000 findings. And you look at that and you just go, how do I even
Findings
do
being vulnerabilities.
Vulnerabilities. And you go, is it possible there's this many, and how does it matter? So what we do with reachability is we look at it and we say, during our process that we use to fill up that SBOM, we do a full binary analysis and static analysis to say, what's going on with this firmware? And then we look at how, whether or not the code in your project actually touches those vulnerable parts. And where they do, we say, yes, that's reachable. Where they don't, we say it's not reachable. Sometimes we can't tell either way, but oftentimes we get great value because, let's say we have those 3,000 results, we might cut that down to 40 that really matter because those are actually reachable. Those are actually have known exploits. These are the most important ones to look at.
Of course, win and wing out things that are not reachable.
Exactly. By the same token, we very frequently find that the vast majority of findings are not reachable, which means most of the products that do what we do, they're saying 3,000 vulnerabilities, but really most of them are not going to be reachable. So what we do with that is we're able to look at those, identify them, mark them, and then into the SBOM, we're able to enter VEX entries that say, hey, we have this vulnerability technically, but it's not reachable. Here's our evidence. And so now when I produce that SBOM to FDA or someone else that needs to see it, they can see that we've done our due diligence, that we actually worked hard to mitigate the issues that we know there are with these particular components.
Great stuff. I would be remiss if I did not mention AI, and it's the 800-pound gorilla. How's that affecting security for embedded systems?
Uh,
In as few words as possible.
I'll
Because
try.
I know it's a big
I'll
subject.
try. It's significantly. I mean, the sense that it is everything and everyone wants it to be everything. And the thing about AI is, you have that 80-20 thing going on. It does 80% of the job really well. That last mile is hard. And so what we've found is still what most of us have found in our lives working with AI so far. LLMs do a really good job of organizing and summarizing. And so we find when we feed it the context that we get out of our process, all of the varying levels of analysis we do, reachability among them, we pull it together and we say, okay, can you help us triage this? And it comes back and says, yeah, these 4 are the most important. You should hit those first. And here's why, based on this data we provided. And then it will say, now, for each one of these 4, here are your options. You could upgrade your component. You could try to don't use that kernel module. There's different things you could do. And because of the context we're able to give that LLM, we're able to get really on-target, useful remediation advice.
Great stuff. Hey, once again, I'm Keith Kreischer here at Embedded World with Roland Lindsey of Finite State. And Roland, hey, thanks so much for your time.
Thank you.
Have a great show.
All right, thanks.